a continuation of section 6.1, which we are on page 2. And this is talking about table A2, which we actually won't be using, but provides all the areas under the normal curve less than a given value. And so also for us, we're going to see wording that will say standard normal distribution. So anytime it says standard normal distribution, we know that the mean is equal to 0 and the standard deviation is equal to 1. So I have a bell-shaped curve here, my normal curve, and the mean goes in the middle. And again, we go 3 standard deviations out using that empirical rule, both directions. So 1, 2, 3. Make sure you do that in both directions. And since our standard deviation is 1, I'm going to add 1 and subtract 1 to go out 1 standard deviation. Likewise with 2 standard deviations, and likewise with 3 standard deviations. So the standard normal distribution must have the following 3 properties. The mean is 0, standard deviation is 1, and then z, our z-score, which is what we're using in order for our standard normal distribution, is found by doing x minus the mean divided by the standard deviation. A z-score, which we've seen before, is the distance along the horizontal scale of the standard normal distribution. It corresponds to the number of standard deviations above or below the mean. Area, again, under the curve is equal to 1. And then it says on the next part down here, it says, then we can use table A2 in the textbook to find the area to the left of the value of the distribution. We will actually be using the calculator, but the key thing here is that to find the area on the other side, like what we did in the refrigerator example, we're going to do 1 minus the area on the left to get the area on the right, and vice versa. So that is the complement rule. So round z-scores 2 decimal places. And then we're just going to cross off the steps. We usually go through this with using the table, but since we're a little changed right now, we're going to go ahead and use calculator steps on page 3. So quickly go to page 3. It's actually at the bottom of page 3. And it says steps for finding the probability of a normal random variable with a TI 83 or 84 calculator. So first thing we're going to do is draw a normal curve and shade the desired area. And then on your calculator, you want to go to second vars. For me, it was normal CDF, it was number 2. And normal CDF, you need to enter in a few things. It's going to be the lower bound, the upper bound, the mean, and the standard deviation. So if there's no lower bound, if it just says less than 6, then we need to type in 1e to the 99. And this is symbolizing negative 1 times 10 to the 99th power, which is practically like negative infinity. This E is not the letter E. It's actually above your comma. So you're going to have to hit second and then comma. And go ahead and put second button in there. And then likewise, if it has no upper bound, we have to type 1e99 or 1 times 10 to the 99th. Which is similar to like a positive infinity, which again, you're into 1 second, comma, 99. Okay, so now we're going to go back up and look at the examples. At the top of page 3. And so the first one here says determine the area under the standard normal curve that lies to the left of z equals negative 0.43. So I'm going to go ahead and say it says standard normal. So if it's a standard normal curve, that means that the mean is 0. And my z value here is negative 0.43, which is on the left. Just think of a normal number line. And it says to the left of z equals this. So I'm going to go ahead and shade to the left of this z value. And I need to find this area that we have. So that is equivalent to saying find the probability that z is going to be less than negative 0.43. So on our calculator, we are going to be using normal CDF. And the first thing that we have is our lower bound. And since this goes on forever to the left, we're going to have negative 1e 99, comma, your upper bound where the shading stops at negative 0.43, comma, the mean and the standard deviation. Our mean is 0 because it's standard normal, and our standard deviation is 1. Close your parentheses, hit enter, and then we are rounding our decimals to 4 decimal places. And so for this one, you should get 0.3336. So likewise, let's try the one next to this. This is a standard normal curve again. So anytime it says that, you know that the mean is 0, standard deviation is 1. That lies to the right of z equals negative 0.55. So negative 0.55 is somewhere over here on the left of 0. And this time it's to the right. So shading that normal curve, I want you guys to realize you shaded more than half of it, so your answer should be more than 0.5. And so we are looking for, this is going to be equivalent to the probability that z is going to be greater than negative 0.55, which again we're going to be using normal CDF. Our lower bound this time, the smallest thing we have in our graph, where the shading starts, is at negative 0.55, comma, and this goes on forever, so 1e 99, comma, the mean and the standard deviation, again, standard normal, mean is 0, standard deviation is 1, close your parentheses, hit enter, and I get 0.7088. Again, rounding that